Alrighty, kia ora everybody. I'm Lenice Evergreen. I'm working obviously at MSL here in the dimensional metrology team. And I'm going to talk about dimensional metrology and food packaging. So why do we package food? So in years gone by, you might have used a box. I don't know if this is going to work. There you go, a box to pick up your fruit and veggies from the greengrocer. This is an animation fail. It's okay, I'll never do it again. A basket to get eggs and a pail to collect milk from the farm gate. The meat from the butcher would be wrapped up in brown paper, tied up with string, and a loaf of bread from the baker, there we go, probably be covered with a tea towel and tucked under your arm. Now, unfortunately, by the time you got home from this epic shopping expedition, the bread would be squashed, the milk spilled, the eggs cracked, the veggies all bruised, and the neighbour's dog probably ran off with the lamb chops. The groceries that you did get home most probably wouldn't even last a week. So thankfully, some smart cookies came up with some ideas to package food so that they could last a bit longer. So here's some reasons why we package food. So we have protection and safety that keeps our crackers whole and crisp and reduces the risk of foodborne illnesses. Waste reduction extends shelf life so that we can always rely on having a tin of tuna in the pantry. Convenience means that we always have tomato sauce on hand. Tamper resistance gives us confidence that no one else has opened the yogurt before you get it home. Portion control lets us know that a snack pack, not a share pack of chips, is sufficient for one person. And branding and differentiation means that it's easy to grab a Coke instead of a Pepsi, or vice versa, whichever your preference is. When it doesn't work, however, we get contamination, like weevils in your cereal, spoilage, where the wine is oxidised and can be more accurately described as vinegar, loss of shelf life, biscuits that go soft, stale and flavourless, consumer disruption, the caramel sauce that's splattered all over the floor, and risk to reputation. No one will keep buying those coffee pots that explode in the coffee machine. Now, I've got a few examples of packaging fails, and they're not all fails, where we've been able to measure the difference that makes the difference. Firstly, here is a standard bottle and jar closure and neck dimensions. Now you have to bear with me here, there's a lot of jargon, I'm told. It's full of jargon, yes. So this is a thread system that is standard across market segments. So you'll find this in fizzy drink bottles, Vegemite jars, squeezy sauce tubes, and even face cream tubs. And it goes from diameters of 15 millimeters up to about 120 millimeters. So a closure is otherwise known as a lid or a cap or any other name you can come up with. And the neck dimensions is simply the bottle or the jar or the tube or the... So I've got a few examples. I've got props. Start off with these guys because this is quite easy to see. Okay, you've all probably got these. I raided my pantry, so you've probably got these at home. Okay, so the thing is that the bottle and the cap are made out of different materials. So this is where you have the problem. So we've got, well, not always a problem, but so the glass manufacturers have to be able to create that thread. And then the cap manufacturers have to be able to match that with something that when you screw it on, you can actually have a closure that means that your cumin seeds don't fall out all over the place. So I'll pass that round and you can play. you can contemplate why that's important. Okay, and now we have one that's fairly similar, so that can come off so you can get your teaspoon or whatever. But then if you wanted to just sprinkle on top of your food, then it's got little cappy things that just pop up. And so all of that has to be designed into the tool before the cap is made. Won't spill the time everywhere. Okay, so that's why these things are important. Okay, so this is my first, so I've got some case studies which I said, yeah, okay. So in this first case, the customer had an issue with milk leaking during delivery to stores. So it wasn't happening in the factory. He didn't want to give us too much information because he wanted to know what we could measure. So we got hundreds and hundreds, actually thousands, of milk bottle caps in all of the different colours that they produced. And we set them up on a CMM to measure the dimensions from the previous slide. H, E, and T, which, yeah, doesn't really help, but there you go. Okay, after analysing all of the data, it was clear that the dark green caps, as a population, were measurably smaller than all of the other colours. And sure enough, that was the colour that was causing all the trouble. So because all the colours are made using the same injection moulding tool, there had to be something different about the raw material. And what had happened was, to get the correct colour saturation of the cap, the industrial chemists had added different additives, and that caused the dark green raw material to have a slightly higher shrinkage value than all the other colours. So reformulating the colour ended up solving the problem. Milk bottle and the milk caps. So you can see that these ones don't have a dimensional difference, but that's what causes sometimes your milk to spill. I don't know if you want to pass those around. Everyone's seen a milk bottle. Okay, the next one. This is a 58mm plastic closure. It's a lid on a Vegemite jar, right? Okay, so this one was a case of process improvement. The customer wanted to know if a cycle time could be shortened from 18 seconds per 4 shot. So what that means is, you see there a picture of the tool that makes 4 of these lids at once. And so as it goes through the cycle, this is an injection moulding tool. So the molten plastic gets injected in, and then 18 seconds later, it injects the next lot of plastic in for the next 4. And so during that time, it cures, ejects, and spits out 4 Vegemite lids. So they were doing that once every 18 seconds, and everything was fine. They never had any problems, but what they were wondering is if they could speed it up. So they came up with a whole heap of samples, sent us heaps and heaps of samples again. Hundreds of jar lids. Can't keep calling them closures because people say it's too jargony. At 18 seconds, so that was the control. Then some at 16 seconds, 14 seconds, 12 seconds, and 10 seconds. So I set up a coordinate measuring machine to measure the dimensions of the caps. And what the analysis showed was that all of the samples that had been manufactured at 14 seconds would meet the specifications of the lids. And minor reworking of one of the cavities, so you can see that's got 4 cavities on the tool, minor reworking of one of the cavities meant that you could bring it down to 12 seconds, and therefore that would lead to a 33% increase in production. So it's pretty impressive. Thank you. Does anyone want to sit my bed tonight? Oh. Okay. Okay, then we had actually the same plastics company that manufactured PET preform. So that's polyvinyl tetrachloride. And preforms are what is used to make bottles like these. So the preform looks a little bit like a plastic test tube with a thread on top. So that's a picture of one there, that's a cross section. And so one company makes the preforms and then it goes to another company to make the actual bottles. So the customer had a problem because due to a misunderstanding, labelling error and general confusion, they had several cartons of preforms of 2 different sizes that had been mixed up. They're very similar sizes, just not the same. So, the preform, when it gets made into a bottle, it gets heated up and then stretched and then blown into the mold to make each individual bottle. But the preforms are slightly different sizes depending on whether you're making this bottle or this bottle. So the thicknesses have to be measured just right. So what we did is, after having a look at all of their drawings, we figured out that there was one diameter that we could easily tell the difference between one and the other. And so all we had to do was to design a go gauge to check all of the preforms. And so we designed it, manufactured it, calibrated it, gave it back to them, and they had a couple of people that have been involved in the mislabeling and general confusion go through all of the cartons, and they were able to really easily sort out one size from the other, thus causing not having to get rid of any of the preforms at all after they were going to dump them. So they successfully sorted out their problem. Now this one is the client of this customer was looking for they had designed a new stock powder container. So you might recognize this one, there, excellent. This design was a huge departure from what they'd previously had, and they wanted to keep the punters on side. So they did a lot of marketing focus groups across New Zealand and Australia. The problem was, this is a push-on cap this time, right? Not a screw, this is a push-on cap. So the problem was, in the focus groups, the Kiwis really liked the push on and a firm positive click to know that it was closed. The Australians didn't like the click, they just liked a shoof and no click. This is cutting edge marketing here. Okay, so the challenge for us was to see whether we could measure the difference between a shoof and a click. So I've got to use my trusty CMM again with a tiny stylus and digitize the snap bead profile. So the snap bead is the piece that comes out that click. So digitize the snap bead profile of several samples of shoof and several samples of click, and found out that the distant difference was less than 0.1 of a millimeter. Now, I'm not sure what the final outcome of this one was. The logical step would have been to update the product specifications as required, but I do know that this design didn't last very long, so I don't know how good the marketing was. Okay. There have been heaps of attempts across the years to find good ways of storing wine. Glass bottles with corks are the preference, but they are very heavy and fragile. So one company that we helped was developing a dispensing tap for bag-in-box liquids, otherwise known as cask wine. Their design was a single-handed front push self-closing tap which optimized the liquid flow rate and boasted an excellent oxygen barrier. That means that your wine doesn't go off. Okay, so the hero of this design was a squishy plastic gland that varied in thickness along its profile. So as you pushed the button, the gland was stretched and the wine could come out but was not exposed to too much. The wine that was left in the cask wasn't exposed to air. So it was really important to get the shape correct, but it's squishy. So you can't touch it because you change it as soon as you touch it. So the best idea would have been to have a non-contact method to measure it, but we didn't have a non-contact method that gave us the resolution required. So in the end, we used a single axis measuring machine with adjustable force to extrapolate and predict the gland thickness at 0 force. So we measured it at 3 newtons, then 2.5 and 2 and 1.5, and then plotted it down until we could predict what the thickness was at 0 force. And that worked. And the new tap was launched. That was pretty exciting. Okay, the final one is when we were approached by an insurance company whose client manufactured pulp and paper, egg trays and cartons. Their factory had been involved in a large fire with lots of equipment damaged and destroyed. A storage room that held most of their egg carton moulds had reached very high temperatures, and although the moulds were not visibly damaged, the client was concerned about warpage. So we measured several dimensions of these moulds. We measured flatness of the mating faces, some of the key dimensions and the shapes, and we even used a little pin gauge to check that the drainage holes were clear and no debris was remaining anywhere, and we found no anomalies at all. And so they went back into the service. They went back into service once the vacuum forming machine had been replaced. Cool. So that's how dimensional measurement can help in reducing the wastage of packaging, because I think we use far too much packaging. And it's a really good idea if we can find ways to reduce, reuse, and recycle. Thank you very much.